So in this segment, I'm going to provide an overview of the microservice architecture. And I'm going to just explain what microservices are. And then actually in the following section, I'm going to describe the benefits and the drawbacks of using microservices. So what are microservices? I mean, there are many different definitions out there in the community. Some people say a microservice is something that's only 100 lines of code. Other people say that a microservice is perhaps 2 weeks worth of work and no more. And there are other definitions as well. So I want to talk by describing what I think of microservices. So a few years ago now, I discovered this really awesome book, The Art of Scalability. And it was written by some people who had a lot of experience operating at scale, both in terms of the size of the engineering organization, but also the size of the system as well. And I highly recommend that you go look at that book. One of the things in the book that really grabbed my attention was their 3D model of scalability, which they call the scale cube. So there are actually 3 different dimensions along which your application can scale. So along the x-axis, they have horizontal duplication. The idea here is that you just run multiple identical copies of your application behind a load balancer. So that's the kind of scaling that we're used to. We do that all the time. We just run multiple Tomcats behind either a hardware or software load balancer. So that's a very sort of monolithic way of scaling. Another option is Z-axis scaling, where you run multiple identical copies of your application, but instead of just behind a load balancer, you're running it behind something that's a little smarter, which actually inspects each request and then routes that request to the appropriate instance based on an attribute of the request. So if this was actually happening at the database level, you'd have a router that would look, say, at the primary key of a row and decide which one of n servers that row should reside on. So that would be sharding. But we can also do that at the application level as well, where you're looking at, say, the customer ID, and you route them to that server, and a different customer will be consistently routed to a different server. So that's Z-axis scaling. And what both X and Z-axis scaling have in common is that you're running multiple identical copies of your application. So in other words, you're just running multiple monoliths. But then there's Y-axis scaling. And this is really what sort of captured my imagination when I read this book. And what Y-axis scaling is about, it's functional decomposition. So rather than running multiple identical things, you functionally decompose your application. So this function is performed by this service. A different function is performed by a different service. So that to me is my definition of what microservices is all about. It's functionally decomposing your application and ending up with a set of services where each one is performing some notion of a function. So if we apply this idea to the online store, we end up with an architecture like this. So the various back-end components or the back-end modules of our application become freestanding services. So the catalog service becomes its own mini application. So does the recommendation service and the review service and the order service. We can also functionally decompose the user interface. Some web applications in themselves can become quite complex, so it makes sense to actually functionally decompose those as well. So we can have a mini web application that's dedicated to supporting the web pages for browsing and searching the product catalog. We can have another web application that's responsible for implementing the checkout web pages. Similarly for order management and account management. So we're just breaking up our system by function into these independently deployable mini applications, or in other words, services. We can also independently scale these services. So each particular service, we can apply x-axis scaling and z-axis scaling independently to meet its sort of availability and scalability requirements. So that, in a nutshell, is what the microservice architecture is all about. It's breaking things apart by function. But there's a little bit more to it. So one of the goals of partitioning our system up, or functionally decomposing it, is to do it in a way such that most changes that we need to make to a system only impact one service. If we can achieve that, then that enables us to do a lot of development and deployment in parallel. So change A impacts service X, change B impacts service Y, and change C impacts service Z. If we can actually work on all of those changes concurrently without a lot of coordination and communication between the developers or the teams of developers that are responsible for each one of those services. So that's one goal that we need to keep in mind. Another goal of partitioning our system up is to actually separate out components that have conflicting resource requirements. So an in-memory database that needs a lot of memory can be run in its own service, whereas our cryptography or image processing components that's CPU, that consumes a lot of CPU, can be running in its own service, because that will enable us to pick the hardware that's best suited to each service. We can put the in-memory database on machines with a lot of memory. We can put the computationally expensive services on machines with a lot of CPUs, and so on. So that's going to help us scale more easily. So that's sort of the big idea. Functionally decompose the system so that we can parallelize development and also scale more easily. So there's quite a few examples of this approach. So here's another geography pop quiz. Where is this? So anyway, in terms of examples, Netflix, of course, is the classic example, primarily because not only do they do this, but they also write about it on their tech blog and at conferences, and they've also open sourced a lot of their components, which can enable the community to build. It provides the community with infrastructure components for building their own microservices. Amazon went through this some number of years ago. They had a monolithic application that they then refactored into a set of services, which today we would call microservices. They don't talk so much about the internals of their system, but one thing that has been mentioned online is that some pages, or rendering some pages, involves the invocation of hundreds of services. And interestingly, if you look at an Amazon product details page, there's a tremendous amount of information on that page. There's basic product info. There's also shipping information. There's also order history. In other words, when did you last order this product? There's 3 different kinds of recommendations. There's sales rankings. There's also reviews. And if you keep scrolling, so it goes on. And you could imagine that each of those little pieces of data is actually maintained by a separate microservice, and there's a web application that's aggregating that data and rendering the page. eBay is another classic example of a company that's embraced the microservice architecture. They actually had a monolith that they ran into issues, and then they refactored it into microservices. And they wrote about it back in 2006. There's also various other companies that have described how they've gone down the microservices route. So for instance, SoundCloud, the audio platform, has written extensively about their migration to microservices, as have Yelp, the review service for business. Great place to find restaurant recommendations. And then Uber, they've actually talked about how they've adopted microservices. So there's countless examples out there. But some of you might be wondering, isn't this just SOA? Well, on the one hand, SOA, service-oriented architecture, and microservices are both all about services. They're about building systems out of services that communicate in some way. So there are definitely similarities. But once you look at a deeper level, I think you'll see some significant differences. So if you think about the technology that SOA app-based applications tend to use, it's usually things like SOAP and other WS star specifications. There's also technologies like enterprise service buses. And in general, there's sort of these commercial vendor or based products that people build upon. Whereas you look at the technology stack for microservices, it tends to be lighter weight, REST, JSON, various open source technologies. Interestingly though, there's a case to be made that the REST, when people first started adopting REST, they sort of left out some critical features, such as the ability to define an interface. And it's only been in recent years that people have started to use IDL definition, or people have started to use IDLs like Swagger and RAML to actually describe their REST interfaces. So people have sort of, those simpler technologies have kind of added some necessary complexity. Another big difference with SOA, between SOA and microservices, is that SOA applications tend to have this global canonical model. So in other words, this sort of enterprise-wide data model that describes the business entities in the system. And the downside of that is that it results in tight coupling. Whereas if you look at the models in microservice architectures, each microservice is a bounded context, to use a term from domain-driven design. It actually has its own model that's basically somewhat private to it. And so they tend to be loosely coupled. Likewise, at the database level, there tends to be sharing between applications. Multiple SOA applications share the same database. So that can result in tight coupling. Whereas in a microservice-based application, each service has its own database, which promotes loose coupling. Also, they can differ in terms of the service size. So SOA applications tend to be large, traditional monoliths, whereas microservices tend to be typically smaller, lighter weight, and so on. So I like to think of microservices as SOA done right, in a way. So kind of SOA in lowercase. And certainly one of the issues that I have with the term microservice is that it places excessive emphasis on size, the micro part, whereas I like to just think of services. So that's microservices in a nutshell. Big idea is you functionally decompose your system into a set of services that tend to communicate using lighter weight open source technologies. In the next section, I'm going to talk about both the benefits and drawbacks of this approach.